Hey everyone. So today what we're going to be doing is just going through data challenge 5 really briefly. It's not a long one at all. And we also went through most of it in class, but nonetheless, still want to throw out a YouTube video in case if people want to be able to recheck this, or, you're going to be using these things in the future. So this way, you know what it is. So the goal of this data challenge is just do some actual like within row cleaning. So there's multiple errors that exist within rows and in different rows, and it's not something we can just quickly take care of on import. There's also different types of errors. So some to which we know what they should be, even though it looks like something, say, misspelled, and other ones in which that we don't know what they should be. And so we got to make different decisions about what we want to do with that. So as always, what we're going to do is get tidyverse in there. And so it's going to attach all our packages as usual. And then we will read in our crime data. So this is a much reduced version of our crime data. So you can see if we go here and row crime, I have only 10,000 rows in here. So it's just smaller just to make it a little quicker and still illustrates the point just fine. So I'm giving you a hint here and saying that there's 4 total errors. There's not as many columns either as our normal crime data, so probably a little easier to work with. So there's a few different things that we can kind of sit here and see. So our date is being brought in as characters, so there could be an issue there, could not, depending on what it looks like. Year and hour are both doubles, so they're being brought in as numeric, so that's kind of what we were hoping for. So we actually got to dig in a little bit more and see. So we can do our usual exploration, so do a summary of crime and see what happens. And so let's kind of see. So day, crime type, date, obviously we can't get much out of this. Year though, right away we see something right here. So we see the minimum value for year is 0. So that should obviously concern us. The other thing that gives me some concern is actually this right here. So the mean of the year column. So remember, this data set, is mainly centered around, say, 2010 to 2016. And so it's kind of strange that we have a median of 2011, which is what we would expect, but then a mean of 1800. And so this is partially probably driven by this 0. So again, it suggests there's probably a lot of zeros in here that's driving down this average mean. So we want to explore within here for sure. Our looks to be overall fine. So let's start by looking here at year. And so we can do this a couple different ways. So we can use unique, and we can do crime year. And what do we get here? Okay, so we have some zeros right here. What else do we have? Okay, so this is also what's probably driving down that mean, is we have 10, 12 in. So kind of looking at the rest of the values, I don't see any 2012s in here. And so I'm leaning towards the idea that this is an error, and this should actually be 2012, where this 0, we don't know what they are. And so we're going to actually want to take a different approach to these two. We can also make a quick histogram. So I'll actually just show you a quick way to make one without going the ggplot route. So you can actually just in base R, just do hist crime year. And then this gives you, figure margin's too large. So if you ever get this, what it's saying, yeah, it wants you to expand that. And so we can expand this up. And so this is just for a quick histogram. Base R is a little bit clunkier sometimes to plot in, but for quick things, it's actually pretty nice and easy. So 2000 we can see, but we have a bunch of things right here that are around 1,000. And then also a few popping up here at zeros. So again, this would be another way that you could identify that, hey, there's some values that are wrong in here, but you're still gonna need to go in and explore using unique like we did to see, hey, what are the improper values? So what we can do is we can just make a little note to ourselves. 10, 12 should be 2012 probably. And then 0 probably should be NA because we don't know what it is. So let's now go ahead and look in some of our other columns. Given I made this lesson, I'm just going to make this a little quicker and say, I know that the errors are in the day column. And so what we'll do again is unique, as I always just like to start there, crime day. And what do we see here? Just some errors for some reason, just some warning messages. And we can ignore those. But let's look right up here. So we can see we have 2 different things. So one of them is Friday's misspelled. Another one is input day. And so I'm guessing what happened here is like Friday, for example, is obviously, or Friday should just be Friday. So that's a simple one. Input day, though, on the other hand, that's one where someone probably forgot to actually put in the day, like they left and they just like left a note saying, oh, I got to go look up this day or something. And so we don't actually know what day those should be, or at least there's no evidence in here that really allows me to like infer, hey, this should be, say, Thursday, for example. I have no idea what day it should be. And so what we're going to do is we will go and so Friday to Friday, and then input day to NA, right? Because we want to be able to drop those or ignore those. And so here's what I'm asking to do. But so we're going to first go here and we'll use some if else's to fix our character issues. And so as you remember, we can test this in one way. So let's say we want to just say assign everything to XXX just to make sure that our assignment works. We can do XXX and then if else. And then we can say crime day. And so if this equals, let's do Friday first and replace it with Friday, Friday. Then we want to replace it with Friday. And if not, we want to just leave everything as is, so we still leave it as whatever was in the given row within that column. So we then put in crime day. Okay, so run that. And so now what we should do, just to check to make sure this worked, is let's just run unique on XXX. Okay, and so good. Our Fridays are now replaced with Fridays, and so that's good. So this works. So let's go ahead and we will then replace the row crime day with then this is if else statement, right? And so what this will do is this will go and fix the values in our data frame crime itself. And so now for our next ones, what we want to do is we can do the same approach of if else crime day. And now we want to take care of those ones where it says input day. And so in this case, we want to replace these all with NA values. And so one issue that I kind of saw pop up was some people were doing this. And the problem is that this way, if it's like, say, seeing, hey, crime day is equal to input day replaced with NA. But the problem is that if it's in quotes, it's actually going to view that as a value itself, a character string, which is not the NA that we want. We want the NA that has the special meaning of a missing data point. And so NAs, if you want it to actually be a missing data point, should be not in quotes. We don't want it to actually be input as a character string. So if else crime day is equal to input day, then NA. If not, we'll leave things as crime day. Run that, and then let's also just check unique again on XXX. Okay, and so now we see that we have some NA values, which is good, but then everything else falls into the standard 7 days a week. So we can go ahead and assign this also back to crime day. And then this will go through and fix everything in crime day. So we can copy and paste and be a little lazy here. Let's see here. Okay, so we can go ahead and run that. And now let's go back and we can run unique on crime day. All right, and here we go. So this went through and it replaced through these two methods. It fixed all of our day issues, both the misspelling and then the unknown values. So now we're good. We have our 7 days. We can move on from there. And so now what we're going to do is we're going to fix these numeric values. Remember, we have this one of 2012 or 1012 we want to replace with 2012, and then zeros that we want to be NAs. So you can use the same method of assigning it to sort of like a test vector or test list right here and checking that. But I feel that sort of we're good enough right now that we can go ahead and just do the reassignment automatically or just in one step. So we'll do crime year and then if else. Not if else, if else. And so what we're going to ask here is if crime year is equal to 1012, then what we want it to actually be equal to is 2012. And if not, just leave it as crime, whatever's in crime year. So we can run that. And then we'll do one more, crime year, if else, crime year, is equal to, in this case, 0, then we want NA, remember, not in quotes, and if not, crime year. Run that. Okay, and so let's go ahead and we can check this in a couple of different ways. Let's go make a histogram of crime year. Run that. Cool. So this looks pretty good, right? So, I mean, obviously our bins are a little funky in some places, but we got 2010, 2011, 2012, 2013, 2014, 15, so on and so forth. So it looks like our data is in good shape, right? We have the range of years that we were expecting that we've seen before in this data set, or that the range of values that should be there. Similarly, you could also just apply unique to crime year. And what do we get? Okay, so again, so a bunch of values and the NAs. Notice how R was ignoring the NAs when it made that histogram. So that's, again, kind of highlights the value of having NAs. So that was it. This is like the sort of process that, although kind of tedious, allows you to go in and fix actual errors. So this way, sometimes you might get rid of data, other times you won't. You're going to actually want to keep your data and fix it. And those are the cases where this kind of row-wise or column-wise specific cleaning can be really, really useful. This way you don't have to toss things that have misspellings or things like that. What's tricky is that you got to sort of make an intuition. These are really obvious cases of, a misspelling, but here this is less obvious. 1012, it might not actually be intuitive that this is 2012 based on your data set. So it's all about you looking at your data and making a decision. So here, what I'm doing is also, I just sort of want to go through this bonus one more time. And so what I'm asking to do is, police officers typically work in 8-hour shifts. And so instead of having a continuous column of 0 to 24 hours as we do now, the other thing that you might want to do is instead actually just bin this into the 3 shifts. If you wanted to ask questions, say, hey, which shift has the most calls? Or you could use it to be like, well, what shift has the most of a specific type of calls? Because we know there's different types of calls in this. And so here what we can do is actually make a different shift column. But the easiest way to do this is something we haven't learned in class, which is to use an embedded if-else statement. So we're going to use 2 of them in the same call. And so we're going to make a new column called shifts. So we make a new column by saying crime, our $ operator, and then what we want the new column name to be, in this case, shift. And so we start out, as always, if-else, but we're going to ask about crime year or crime hour. Okay, and so what we're going to say, if it is, and so since I'm saying that the first shift is from 7 to 15, so 7 a.m. to 3 p.m., so if it's greater than or equal to, because the shift started at 7, and it is less than, so crime hour 15, then, add some more spaces, less than 15, then what we want that to be is first. Okay, cool. So that's going to be the first, but so what we need is the last part of the if-else statement. So if this is true, then this. If not, then what? But we still need to create 2 more shifts. And so remember, you can create 2 things within a single if-else. And so what we can do is put in another if-else right here. So if this is false, then another if-else. So we can again say crime, and now let's make our second shift. Hour is greater than or equal to, and now we'll do from 15, and crime hour is less than, and the shift ends at 11 p.m., so 23. Then it's second. And if not, then it's everything else third. And so this should work. And so what do we see? So we can look at this hist shift. It's numeric, sorry. So what we can do is first check crime shift. Okay, so first, second, third, and then we can also just sort of look at that column, or we can do a glimpse here. Struggling to type. Crime. And so this is here, what you can see is here's our hour, right? So this is before 3 p.m. 15, so it's first, same. This is before 3 p.m., right, is our hour. So now this is at first. This is after 3 p.m., so this falls within second. And you can go on down the list and sort of see how these hours are matching up with these shift categories. And so then this is useful to go through and then have these like three simple bins rather than a number of different hours if you want to sort of make inferences about how busy individual shifts were. So that's it for Data Challenge 5. Once again, please give me feedback. Feel free to leave a comment, anything like that.